follower or subscriber till date. I'm glad you're here. I'm glad you've joined. I'm glad you're watching this stream along with everybody else that's here. So, guys, everyone, we're working on how to test contracts using Truffle, and we're going to start with our first contract. I don't know what the curriculum actually says. Let's go have a look. Let's see if it loads. Here we go. Do 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 do. So if everybody else wants to follow HGH288's example and give me a follow, that'd be great, or subscribe rather. So sample contract number 2. We already sourced the contract. We don't really have to talk about open source. Hey, Haley.
Hi.
So basically, we're looking at really this first point and the second point together. Whoa, what's going on? Click, click, click. Okay. So what we want to do is look at the tests within our multi-sig contract. Or I actually just broke my order of thinking. Don't you hate that, man?
I do.
What did I break here? I broke everything. I broke everything, man. I broke everything, man. Okay. So for the multi-sig contract, we're going to look at the tests and see what we're trying to test. Now, the idea behind a Truffle test, or a test file, or a test run of a contract, is to see the outputs of the test of the things we're looking to test against what the actual contracts give you. So here we are in our multi-sig contract test folder. We see there's JavaScript tests. There's a whole bunch of them. So we'll start with, I guess, what do we want to start with? Well, let's just look through them each individually in order. So 1 day is equal to 24 times 3,600 seconds. That's just used later somewhere in the test. It's requiring the utils JavaScript here, which basically just gets parameters from transactions, mines blocks, increases timestamp, balance of an account, and assert throw to asynchronously. We want to assert stuff asynchronously against the blockchain. So we're requiring that. We're going to use that later as part of our tests. We're going to deploy a multisig, which is going to return a new multisig wallet contract, which is using this file here. So what do we want to do? We want to have a multisig instance, and we want to make sure that our required confirmations is at 2. Before each of these test items, we want to create a multisig instance by deploying a multisig with our first, second, and third account inside of our test RPC. No, yeah, exactly, yeah. That's the accounts that we're going to use for the multisig, just like I did when I deployed the multisig in our last live stream. And a required confirmations is 2. What that means is, sorry, not the blockchain confirmations, but how many confirmations we want. So we're doing 3 accounts with 2 confirmations, meaning it's a 2 out of 3 multisig for every one of these tests. Then we want to assert that that's okay and that we have that. Hannah's contacting us for some unknown reason. Oh no, those are the ones from Saturday. Let me just talk to him real quick. So there's just some confusion about the fact that I've published new videos on the contract that I was working for Hannah. But I told him I couldn't do anymore because I'm too busy with live video, publishing 4 live streams a day. So we're looking to test execution after requirements change. Now I'm not sure what that means, so let's see what happens here in the code. So we're going to send money to the wallet contract by sending a transaction to the multisig address with a very small way value of ETH. We're going to get the balance by doing balance of. We're going to make sure that the balance is equal to the deposit after it's all been done. That's one of the first asserts. So every time we run one of these asserts dot equals or exactly equal to or whichever assert we run, we're asserting that something is the way that we expect it to be from the test and the actual result. Add owner data. So we're adding the fourth local address as an owner um, by making sure there's one pending transaction. We're updating the required the required number of total confirmations to 1 so that it's a 1 out of 3 multisig now. So we're changing the requirement using the change requirement function on the smart contract, um, and then sending that transaction. Now we're making sure that there's 2 transactions there. Then we're confirming the change requirement transaction, which means we're confirming using another owner that we want to change the required amount of transactions or confirmations. And then it fails in this instance because the owner is not the wallet owner, meaning that you're not the person that's owning the wallet. You're not one of the owners. So it's going to fail in this instance, and we're going to check to make sure that it fails. I just changed files by mistake because the number of required confirmations changed to 1. The add owner transaction needs to be executed now. So now we're going to execute that add owner transaction and make sure that it gets executed. That's that test file. So we're just testing adding an owner, changing the required confirmations. Now let's see what happens in this particular file. So we're doing a multi-sig wallet. Before each of them, we're going to go ahead and deploy a multi-sig contract. I guess we're deploying a token. I guess we have a test token inside of our multi-sig contracts, which is good, in our test token file. So we're going to deploy that test token. Test calls we're going to deploy. We're going to deposit a bunch more way this time. We're going to send money to the wallet contract before each of these tests. So this test here, this one here, is going to transfer with payload size check. What we're going to do in there, we're going to give tokens to the multisig wallet from the first account where the tokens exist. We're going to transfer them and then create the transaction for that and execute that transaction. So we're basically just giving tokens to the multisig wallet here. And then we're going to make sure that the token balance is equal to that using an assert call. Now we're going to fail with the transaction. Without issuing it first. And we expect that to fail. We're going to make sure that actually failed. The test below can only work if the multisig wallet above allows non-zero destination. So this one's all commented out. We'll skip that one. This one's call receive one uint. What we're doing here is calling the receive one uint or L uint function on the contract. Submitting that transaction, getting the transaction ID, confirming the transaction, checking that the transaction has been executed, check that the expected parameters of the end values were passed. We're going to make sure that the calls instance has these values here, as well as this value for last message data length and this value for last message value. Whew. And then 2uint's going to do the same stuff, except have more asserts at the end. Call receive 1 bytes. We're going to do 1 byte worth of data and make sure that it all equals out in the end. Let's go to test multisig wallet with daily limit. We're going to create a daily limit of 3,000 way and 2 out of 3 confirmations. No, 2 out of 2 confirmations required with a daily limit. We're going to create that multisig instance. We're going to deposit some money into that multisig. We're going to, what am I going to do? Submit a transaction to take some of that money out. We're going to make sure that, some more stuff happens. Either way, you can test for whatever you want, and that's kind of the point of this project, is that we're going to look over all these different kinds of tests and see what you can do. We're going to update the daily limit here and make sure that worked. Whoops, what did I do? What did I do? We're going to go ahead and assert a bunch of different stuff, making sure the daily limit works and that we can withdraw under the daily limit and that it fails above the daily limit. So basically, when you do a multi-sig contract, you could say that there's a certain amount up to a daily limit that you're allowed to withdraw every day, like zero point 0.1 Ether or whatever it happens to be, with any address without any confirmation from anybody else, and that's all that this file is testing. Oh, I just broke it again. I'm hitting right click too much. If we let one day pass inside of our test and then try to withdraw again, it should work. Except if we withdraw over, which is this testing, and we make sure that all the wallets decrease and decrease. And here we have the daily limit factory, which is going to create a multi-sig factory and test everything that it can do, which is just create different multi-sigs and make sure that it can actually do that stuff. I don't know what the Python tests are going to do. I don't think we need Python tests because we're not using Python, so it's not going to do anything. It's just going to do the JavaScript test. So if we go into this folder and run the tests, cd, actually we're in the folder. So what we want is truff test. Actually, that's all in the next, well, we can do it right now, I guess. We could actually just change the order of stuff again. The order of stuff. So do you have any questions about all those tests? Basically, what a multi-sig contract does is save money for you, and there's different ways they can use it, and that's basically just testing to make sure everything works the way that it's expected to, right? Which is what you want to do with tests. You want to make sure that stuff equals exactly what you try to put in. But do you have any question about any of those tests?
Earlier you said NPM.
Yep.
What does that stand for?
Node Package Manager. That's how you install stuff using Node that you can use elsewhere in Node.
Oh, Node Pro
Package Manager.
Package Management.
Yeah. So look at this. We did 8 different tests. The multi-sig wallet, this second test on the multi-sig wallet, which does the second file's worth of tests. This third contract, the multi-sig with daily limit, and then the factory. And everything passed. Everything is behaving exactly the way we expected it to, which is good. So if guys, if you want to review, I think our first live stream from today, I can't remember. You'll see that we actually created the tests that are inside of our decentralized application, which is this very first folder here, the elections smart contract we were going through. We actually built those tests as we were going along, and I told you exactly what they did, which is basically make sure that the IDs and the names and the vote counts of each of our objects that we created, and we actually manipulated this test as we went along and made sure that when we added another third candidate, it still tested properly. Except we never ran that test. Let's try running that test. Hello, live video moderator. That's my boss, I think. I wonder how many people we have in here. 18 people. Hello, everybody.
Hello.
Oh, never mind. I broke my my test by throwing in Truffle.js from account that's not there anymore because we're using a local test RPC. Try again. Because the from account was from rinkeby, and we don't have that account inside our test RPC. So it should default to the first one now. And we broke something. What did I break? Election.js 37. Is that the test? Yeah, it's the test. I broke something, man. What did I break, man? 37. Do I not have enough close brackets? Do I have too many close brackets? Yeah, I do. Code is so fickle, man. Code is so fickle, man. I broke something else. It then is not a function. I broke my test, man. Oh, I know what I did wrong here. This is what I did wrong. Try that now. Hit then, man. So we're failing a test. I wonder what we're failing. Initializes with 2 candidates. No events were emitted. Initialize with the correct values. Assertion error. Expected object equal to. What did we break here? Three is what we want here on this first assert because we have 3 total candidates now. We want to make sure that the count is equal to 3. So I just forgot to update that when I was updating this test. And again, you guys can review that previous live stream if you want to see what that looks like. Now we're passing all of our tests. So that's good. Now, unfortunately, that didn't take nearly as much time as I wanted it to. We're only up to 16 minutes. So I'd like to know how we continue, because we can stop this particular session now, go grab a break, and come back for another session. But we're going to end up doing a whole bunch of these Truffle contracts. Maybe what we want to do is look up Truffle test examples. Testing smart contracts with Truffle. Let's see what this article has to say about what we're trying to accomplish, because going through the test and then doing the test wasn't really that enlightening.
Did it say noob up there?
Yeah, it did. Yeah, I was talking about noob stuff. A 101 noob intro to programming smart contracts on Ethereum. That's his first article. We've already avoided all that stuff, or we've already done all that stuff, rather. We're well beyond noob now.
I just haven't heard anybody. They're not be called a noob, but I haven't heard the word noob in a while.
No, it's definitely used in the tech circles. It's something that geeks like to call each other. What?
I just thought it was funny.
This is just telling us stuff here. It's not
Lots
really
and
good.
lots.
I'm dying. I'm tired, man. It's just telling us to test everything and the different things we can do in tests, which is cool. I guess something that I didn't know you could do was a console log. So if I was inside one of these tests, I could actually do console.log and log variables or stuff to the console. So let's just see if that worked. Console.log, man, which is good information to know. It's always good to know you can log stuff. It does say ooh la la. Check it out, Haley. I made it say ooh la la. Ooh la la. Ooh la la. Well, I think we have a problem with our truffle contract testing project because it's not going to take as much time as I expected it to go through each of these tests. We've actually done 2 different smart contracts here on this particular session, and this has only been less than 20 minutes now. So Paydar's off. He's going to bed. We should have our payment tomorrow for that first project.
Okay.
And we're up for another 3 hours. So I wonder what to do here. I wonder if we can build the contract and build tests for it as we build it. But the thing is, we've already done basically all the examples we're looking to accomplish. I wonder if there's another example of one that doesn't have a test that we could build a test for. So one of these does not have tests. This contract here is the one we'll do in the next session. So we'll get involved in that in the next session, explain what we're doing, explain how to accomplish it, explain what we're up to, and change these around a little bit. We're going to add this is so laggy. Plus, what was the first one that we had there? Voting contract. Anyway, I'll do this all off stream. and let you guys have a break. We'll be back. We'll do the third sample contract, and this time we're going to go ahead and build tests as we go, and we'll probably learn more that way for building tests for stuff that we don't already have tests than we did by just going through tests and reading what they did and then executing them, because as we see, not much really happened. So everybody, if you want to give me a follow, that'd be great. Give me a subscribe, and we will be back in the next 3 to 5 minutes. What we just covered is how to do the read a test, see what it should complete, and then watch it complete that, as well as log into the console and changing some features of a test that we had built previously. All right, so I'll be back. Haley will be back, and we'll be here 3 to 5 minutes from now.